Maybe let me start with a question. So, what if you could, instead of blocking a receptor transiently with an antibody, if you could actually permanently and selectively remove it from the plasma membrane of cell of interest? That's what we're doing. That's what drives our science at Laigo Bio. My name is Richard. I'm the CSO of the company. The company is based in Utrecht in the Netherlands. The company is basically focusing on precision membrane target degradation using bispecific molecule that we call SureTACs. The company was created in 2022 following the work from Madeleine Morris at the Medical Center in Utrecht through the support of Argo Bio Studio. We are targeting plasma membrane protein in two different indication or therapeutic area, which is autoimmune diseases and oncology. And we're going with precise degradation through the use of tissue and cell-specific E3 ligases. We have a growing pipeline that I will be presenting later. And we just recently announced our oversubscribed seed financing of 17 million euros that help us to advance the platform and the pipeline with our first ambition to have a DC nominated next year and the Series A in the first part of 2028. So if you compare to conventional strategy of antibodies, which are mainly aimed at blocking protein-protein interaction or are inducing cell death through the Fc portion of the antibody, with SureTACs, which stands for Surface Removal Targeting Chimeras, we are going with event-driven pharmacology. So the ambition is to bring in close proximity an E3 ligase and a protein of interest, and this close proximity induces the ubiquitination of the target, then its internalization and degradation through the endosome. These have several advantages over the conventional therapies because we've got this durable pathway silencing because you're actually removing the target. Through the careful selection of the E3 ligases, we can have some cell and tissue selective expression and targeting, which also increase the safety profile because you don't need to degrade the protein of interest in every tissues and in every cells. Because we are not dependent on functional blockade, we've got a bigger potential for new targets. And I think actually we are, really keen on going after non-blocking antibodies to avoid, for example, superagonism. And we are also able to go after undruggable targets. So those are the targets that either have unknown ligands or multiple ligands, difficult to target with a single antibody, or complex molecules such as multimembranes like GPCR. When we've got a new target, the first aspect is to match the E3 ligase, an optimal E3 ligase with the target of interest, and we do that using the TAC screening platform. If you consider that in your genome, you've got about 650 to 700 E3 ligases, about 10% of those have a plasma membrane domain. In our TAC screen, we are working with 28 E3 ligases at this early stage. And we basically have the ambition of matching these E3 ligases. So we overexpress them. They have a certain tag. And the target of interest have a different tag. And using a tool reagent that can bring those two proteins together, we can identify which E3 ligase is relevant for your target of interest. And obviously, this is an artificial overexpressing system. So we also have to make sure that the target and the E3 ligases are co-expressed in the same cell and in the tissue of interest. And this is why we're backing that up with bioinformatics. So our ambition is really to develop this plug-and-play system where we have E3 ligases that we can then binders that we can then combine with target binders. At this stage, we've got 14 tissue-specific E3 ligases at different level of characterization, and we're also developing our own binder through internal work, so we can work with VHH, with single domain, or with Fabs, and we also have those collaboration. And one of the obviously important collaboration for the reason I'm here is to develop a fully human antibody using the chimeras for one of our targets. But really the ambition is when you have both binders is to create those molecules, the SureTACs, which are based on knob-in-hole technology. So they have a lot of the properties from antibodies, both in terms of production and the way you test them into a battery of in vitro and in vivo assays. This is our pipeline as it stands at the moment. We've got 2 programs in oncology that are most advanced based on historical reason. Oncology was the first interest of the company. We've got a trispecific molecule based on a proof of concept SureTAC targeting PD-L1, which we also combine now with an anti-VEGF blocking moiety. And we have a really exciting program targeting Wnt signaling. And this is one of these undruggable targets, and this is targeting LRP6, and I'll come back to that program. In terms of the autoimmune diseases, at the moment we've got 3 internal programs at different stages of development, and one of them is the collaboration with LifeArc, and we also have a nice collaboration with a pharma partner that's going really well. So just to give you an example how it works, this is a proof of concept SureTAC targeting PD-L1. Here we're looking at M38 cells expressing PD-L1 at the surface of the cells, and we've got a control SureTAC that doesn't recognize PD-L1, and a PD-L1 RNF128 bivalent molecule. And if you can look at the expression, you can see that in response to the SureTAC, the target is, this is only a 4.5 hours experiment, you can see that the target is rapidly removed from the surface of cells. We've confirmed removal using orthogonal methodology, so this is Western blot. Here we've got different binders to PD-L1 and different binders to RNF128, and we can see this really strong removal of the PD-L1 from HT29 cells. We also tested different E3 ligases. You can see the efficacy is dependent on which E3 ligase you're using. This is why the screening we're performing at earlier stage is really important. Here we've got, Here we've got a time course experiment done by flow using non-competing antibodies and PD-L1. And here we're testing monovalent anti-PD-L1 SureTAC or bispecific SureTAC. And you can see in a dose-dependent manner that we are removing PD-L1 from the surface of the cells really quickly in a dose-dependent manner, but also maintain for up to 4 days in this experiment, arguing for a stoichiometric but also a catalytic effect of our SureTACs. Obviously, removing the protein is one thing, but is this resulting in efficacy? So here we've got a co-culture experiment where we treated tumor cells with the SureTAC and compared it with the anti-PD-L1 atezolizumab from Roche Genentech, which the cells are incubated with the drugs for 4 hours, then co-culture with PBMC, and we're looking after 48 hours at tumor cell death, looking at LDH release. And as a positive control, we're lysing the tumor cells with a chemical reagent, and that's normalized to 100%. If you have an isotype control for the atezolizumab, you've got some background lysing of the tumor cells. Atezolizumab increased the signal, but you can clearly see that the SureTAC was much more active at inducing the tumor cell killing in vitro. We moved this molecule in vivo using a syngeneic model, MC38, which is a model known to be resistant to PD-L1. It's something we've confirmed by treating with atezolizumab, which is cross-reactive to mouse protein. We've got an improvement in terms of overall survival and improvement in terms of overall tumor volume, decreased tumor volume, which was okay. But what was more important for us was to demonstrate in vivo that we could get this targeted degradation in the tumor microenvironment. And this was shown here by looking at protein extract from the tumors, and we can see that the animals that were treated with the SureTAC show a massive decrease in terms of PD-L1 expression. Another aspect we wanted to prove from this experiment is this tissue selectivity. And for that, we use IHC, looking at PD-L1 expression in the tumor, but also in the lung. And we can see that in the tumor, we had the decrease that we were expecting, but more importantly, we managed to show some selectivity to the tumor because the expression of PD-L1 was maintained in the lung, again, arguing for a better safety profile and this tissue selectivity that is driven through the selection of the E3 ligase. So this molecule, which was a proof of concept SureTAC, is now moving into the next generation, and we've got this trispecific molecule with is basically the bispecific PD-L1 SureTAC with a VEGF blocker that is now entered in the in vivo experiment and pharmacodynamic experiment. The second program in oncology that I wanted to talk today is about this undruggable target. So we are going after Wnt-addicted tumors, tumors that are ligand dependent, and through the targeting of LRP6, which is one of the core receptors of Wnt signaling. We're going after this side of the equation. So we're going after tumors that are Wnt addicted, so either through upregulation of the Wnt ligand or through mutation in certain protein like E3 ligases as well, RNF43 and ZNRF3, or responding fusion that basically induce either high level of the ligand or really high expression of the receptor, resulting in active signaling pathway. This is about 10 to 20% of cancer. It could be cancer like colorectal cancer or pancreatic cancer or even ovarian or gastric cancer are showing this type of mutation. And we can't go after the one that have intracellular mutation in beta-catenin or APC. So here again, we've developed a SureTAC against LRP6. It's a different E3 ligase to the previous one. In this in vitro experiment, we treated HT29 cells with the SureTAC and look at different time points for target degradation through Western blot. And we can see that even after 1 hour, we start seeing the signal going down, and the signal keep going down until to 20 hours. We're actually extending now this experiment, and I'm going to show you a later time point in another experiment. We see target degradation again. Is it associated with blocking the signaling pathway? Here we're using HEX cells that have been knocked out for, double knocked out for the mutation that I've mentioned in those patients. And then they're transfected with a reporter construct to look at Wnt signaling. The positive control is normalized untreated here. We're using this LGK molecule, which is a porcupine inhibitor. It's a really strong Wnt inhibitor, but extremely toxic in vivo. But clearly showing what window you've got in terms of the experiment. We have a negative control in terms of SureTAC here, and then we're testing two different SureTAC against the same LRP6 domain, but against two different E3 ligases. And we can see in a dose dependency an inhibition of the signaling pathway with one of the SureTAC potentially slightly better than the other one. We move into a bit more complex models. Here we are going after organoids. So those are patient-derived organoids that from colorectal cancer patient, again, harboring the same mutation that we discussed in the past. We can see here at the Western blot, so those are longer time point than the one I've shown before, that the SureTAC is inducing removal of the target up to 92 hours. When we test the effect of the SureTAC in the proliferation assay of those organoids and compare to control, we can see that this is the non-specific SureTAC. We've got monovalent SureTAC, either only targeting LRP6 or only targeting the E3 ligases with no effect. Here we have two different SureTAC against two different E3 ligases, with one of them showing this strong inhibition of the growth of the organoids. And if we go up to 21 days in this experiment, you can see that this SureTAC is associated with a growth inhibition quite similar to what you would see with the small molecule inhibitor. So this molecule now just enter in vivo testing. We're testing it in CDX model and also in PDX from different type of cancer with the expected mutation we want to go after. In terms of the platform, we quickly realized that there was a lot of value as well outside of oncology for the same argument that I've given you already for the oncology program, but maybe a couple of things I want to highlight. Because we are monovalent against the target, there's really a lower risk of having this super agonism that you can see in, with antibodies. And we're also going after non-blocking, which even further decrease that risk. So that's quite important for I&I target. The other thing we're spending quite a lot of time is to understand the expression of E3 ligase in different immune cell subtype, whether they're myeloid cells or T cells or B cells, which basically will help us to select with a strong rationale which E3 ligases we want to go for each target. And in terms of where we are, so the targets are anonymized because we are really early stage. We've done quite a lot of work to see where our platform could be of benefit for certain target, and we're going after indication with high unmet needs where those targets could be of interest. And one of the key collaboration is for this first target we've got with LifeArc, and the contract was signed just before Christmas, and as we speak, the humanization is ongoing to generate fully human antibody. So just to conclude, I hope I was able to show you that we can deliver the next generation of protein degrader. We have a differentiated pipeline, and the way we screen, if you have to remember one thing, what we're doing is to really match E3 ligase to the target. That's the way we want to portray ourselves. And we are now having a growing pipeline here that we are advancing to the next stages. We also now moved to a new lab in Utrecht at the beginning of January, and we are growing the team. So this is a massive thanks to the team in Utrecht, A few more people should be added to this slide. Also to thank our advisory board that support us in terms of science and drug development. Obviously, we could not do this work without our investors from all around Europe. And finally, but last but not least, LifeArc for this collaboration we just initiated, and we're super excited to keep working with you. So without, thank you very much for your time, and I'd be happy to answer a few questions.
Thank you, Richard. That was great. And we have time for a few questions. We're comfortable, so please shoot. Give the mic from here, second row. Thank you.
Hello, thank you so much for this excellent presentation. I was wondering, in terms of the FC status, like FC engineering, is your FC capable of mediating effector function, or have you chosen to silence it?
So most of the program we've got at the moment is silence AFC, so we're using LALA-PG for mutation to avoid any ADCC, ADCP, and complement activation. The model itself is just based on a knob in hole, so it's but it's yeah, we can play with any mutation that you can play with antibodies, really. My pleasure.
Hi, is the antibody released prior to the target internalization and degradation?
So we've got already evidence of catalytic activity, you know, as you would see with PROTAC. I think it's target and biologic dependent, but it's something we want to further understand. And at the moment, you know, we're looking at how we could play as well with the binding. Obviously, as soon as you've got internalization, pH-dependent binding could help with the recycling. So your target goes into the late endosome, but through pH regulation, the SureTAC and the E3 ligases could be recycled to the plasma membrane. But we already have some evidence of catalytic activity.
Hi, Richard. Thanks for the great talk. With intracellular E3 ligases, they are pretty widely expressed, and there's a debate saying that, you know, you can't be really tissue specific with these ligases. So it looks at it could be quite different for cell surface E3 ligases, because you talk about specific cell subtypes that this is quite uniquely expressed, perhaps. How unique is that expression, or is it still found elsewhere?
So two aspects. First, around the level of expression. You know, I think between the E3 ligases and most of the targets we're looking, you've got maybe 1:40 to 1:100 ratio, E3 ligase to the target. So, you know, you still have a massive on the side of the target. So that's the first aspect. In terms of the selectivity and specificity, you don't have necessarily an E3 ligase that's only expressed on a certain immune cells or whatever, but you can clearly see certain cell subtype, you know, myeloid cells or T cells that are showing increased expression of certain E3 ligases. So it's not exactly specific, but it's selective, I would say.
Hi. Does your approach work against targets with both high receptor copy number on the cell and low receptor copy number on the cell?
Well, in terms of, you know, the targets we're going after are relatively highly expressed, I would say, at this stage. I don't think we've got enough data to tell you at what level up or high those SureTAC are working. It's not something we've looked at yet.
Time for one more question, a quick one.
Hello, I'm the chairman of Laigo.
Hi, Neil.
Hiya. I just want to answer your question about, in oncology, choice of ligase is different to immunology. You may know that in oncology, the ligases in certain cancers, not all cancers, are upregulated. And so it seems to be quite selective when we've looked across. There are certain, so for example, in our lead, we're looking at colorectal cancer because the ligase we're looking at is actually upregulated. So as part of our choice of ligase, first it has to degrade, but then there's an upregulation of that particular ligase in disease. And it's probably the coping mechanism of the tumor. It's taking off everything that is a target for a T cell. It's just taking it off by upregulating. So if we actually take off the ligase, it's actually also not just the actual target, but the ligase, take that off, it makes the cancer cells more vulnerable as well. Whereas in immunology, the actual targets are far more selective for cell type in themselves. And as Richard says, there are selective, like the marchers, for example, are very selective for immune cells. So we're working with ones that are relevant to immune cells, but we could work with others, but it's obvious choices for immunology, immune cells, clearly. So it's that, if that answers your question a bit, yeah. All right.
Thanks, Neil, for your answer. Brilliant. Well, thanks a lot, Richard. It was great to have you on stage.
Cheers.